So again, my name is Sergio Pages, or Pages, for those Americans here. I'm originally from South America, so you might hear a little bit of an accent from me. I've been in this industry for about 30 years, primarily working for a national company called StructureTec. We're an engineering and construction company, and what we do is we specialize on the exterior of buildings, making sure that things are weatherproofed, in terms of protecting the inside of the structures. So we deal with structural issues, weatherproofing issues, and so on. My talk today, I'm trying to link this theme of, having good buildings, healthy buildings, in order to attract people back to work. I think many of you will share this challenge that we're having. I was talking to a couple of colleagues of being able to bring back the former employers that were working in our offices. They are now accustomed to working, from home, and it's becoming a challenge. I have a particular client. They're a multi-billion-dollar automotive company. I'm actually I'm based in Detroit, so I deal with a lot of automotive companies that have a national footprint. And they're really struggling, so they decided to right-size, and we're starting to restore some of their buildings, and then slowly decommission some of the other ones because they're going more into a hybrid mode. I also have a son who just finished college, and he started working for Google, and they have a policy of 3 days in the office, 2 days at home. So if you're going to be coming to the office, you want to make sure that the office is at least, up to par. And the envelope is a big part of it, because if you have leaks or if you have air infiltration, that's going to affect, and there's actually proof that it affects performance of people. So with that, let me just start with some learning objectives. My goal today is to share with you some sustainability strategies on how to reduce operational costs when it comes to the envelope. Envelope obviously consumes a lot of energy, or it's able to control that. And how does sustainability affect employee engagement? We'll talk a little bit about that. How does the building envelope relate to the operational goals of the company? And how does a proactive facility management approach relate to cost reduction opportunities? And I'll show you examples. It's not just going to be theoretical, but some examples. I'm going to start with this article. And by the way, I forgot to introduce my colleague, Megan Shovel. She's in the back. She's been passing a clipboard because I have a lot of articles that I like to send you. So if you provide her with your email, we'll send you the articles. And this is one of the articles. It's actually based on this book, and it's by Harvard Laboratories for Buildings. And one of the things that I learned from this book after reading it is that they're basically applying health principles to the maintenance of buildings. So this is another angle on justifying building envelope maintenance. And they basically said that these are the different strategies that you can use to make sure your building is healthy. The one that I'm going to focus on is basically engineering controls and spaces, because that's the part that we can control in terms of the actual infrastructure. The other thing I learned from this article is that there's really 9 foundational strategies that you want to focus when you're trying to maintain the building healthy. But of all these 9s, the ones that I'm going to focus on is basically, where the envelope makes a case is ventilation, air quality. If you have a leaky building, air quality is going to be an issue. Thermal, moisture. Moisture is obviously a very critical component if you're allowing moisture to come in, especially for those people who are managing hospital or healthcare. Anybody from the healthcare industry here? So moisture in a building is not a good thing, especially for patients. So these are the 9 foundational things that we need to focus on when it comes to the envelope. And then some statistics that I learned from reading this article, and you'll see them when I send them to you, is that just a percentage of change in temperature of the building can really affect the performance of your employees. The other statistics that I learned from this is that, hold on a second, let me get my glasses, is that the sick leave is also related to poor ventilation, which I did not know. This was actually a study that was done by Harvard Labs. Hold on a second, let me get my glasses here. So so these are basically some foundational things about maintaining your building healthy. Now let me start with some best practices on how do we maintain that building watertight and weathertight. And I'm going to share with you what I call 3 areas of sustainable best practices on how to maintain your envelope program tight. And the first one is prioritization. Prioritization relates to, we all manage a lot of facilities. Some of us have portfolios that encompass the whole country, or some of us have large campuses in a particular location, but we have a lot of buildings at different stages of service life. So how do we prioritize all the needs? Because everybody's competing for funding. And then how do we come up with cost reduction strategies when we're implementing programs for the envelope systems? And then lastly, I'll talk about sustainability strategies that we can use for aligning with sustainability for your organization. So before we go further, let me describe a little bit of the envelope. So what is the envelope? The primary function of the envelope is to protect from weathering. And these are all the different systems of the building envelope systems. You have roofs, you have sometimes terraces, you have exterior walls and air barrier systems. You also have below grade systems. And parking structures is also another component. Below grade is a particular area that we, at our company, we call horizontal restoration, where it comes to below grade weatherproofing of systems. So how do we develop a program that encompasses all these systems? And then just to put it in perspective, the cost of the building envelope system as compared to other systems is usually about typically around 20% of the cost of the whole construction in a brand new building. So it is an important asset, but unfortunately it's hard to make a case for the building envelope when you're competing with other systems that are not as clear as, for example, when you're trying to ask for a roof replacement project, it's out of sight, so it's difficult to make a business case for that, but yet it's an important component of the building. I got this quote from an author, and this is the battle that we're struggling with. Another flaw in the human character is that everybody wants to build and nobody wants to do maintenance. And that's the fight that we're dealing with. In my 30 years, I've been struggling with this, trying to help people like you make a business case for justifying a building envelope project. It's very challenging. So how do we go about that? How do we make it so that we can make a case for those projects? Because otherwise, when they leak, we're going to get into a situation where people are making decisions that are not necessarily the best. Actually, I got this picture from an article on a newspaper that it was literally true. This individual they were fighting for roof money and they couldn't get it. So I'll start with a quote that I think will give us kind of a basis for prioritization for my first topic. And this comes from an Admiral, James Stockdale, and I'm going to repeat it a couple times. You must never confuse faith that you will prevail in the end, which you can never afford to lose, with the discipline to confront the most brutal facts of your current reality, whatever they might be. Okay? So we must confront the most brutal facts of your current reality. Now he's talking about more of a war situation, but in a sense, we need to know the facts about our buildings. If we don't have those facts, we're not going to be able to make a case. And a lot of us are so overwhelmed that it's hard for us to collect those facts. So what I'm going to share with you is a systematic way of collecting those brutal facts so that we can make a strong case for the building envelope projects that we may have. So prioritization is key. Like I said, you need to have a roadmap in order for you to know how to restore the weatherproofing integrity of your building envelopes. Without a roadmap, we're not going to have a clear picture, you know. So the intent is to have those critical facts about why is it or what is it that I need to prioritize. And I'll start with some questions that maybe will preface something for you to ponder on. So what are these brutal facts? One of those is in what condition are my envelope assets at a given time? What condition they're in? That's an important component of the question that we're trying to ask, or the answer that we're trying to get. How much service life do they have left? You know, what point are they all have a determined service life, so how long until they start failing on us? The other question is, what can I do to extend the service life of those systems? A lot of people don't think about that, but there is ways to extend the life of a window system, of a roof. And when do I need to plan to replace them? There's a point where they run to failure, you know, we're done with it, so at what point do I need to replace them? And it would be nice if I know that ahead of time, so I don't come to the board or the administration asking for funding right now, you know, where, you know, I didn't plan for that. So when do I need to plan to replace them? And then the most important question, how much money is going to cost me? Okay, so let's start with, how do we get those brutal facts? Obviously, we need to do a physical inspection. Okay, we need to get boots on the ground and look at things. So we got to assess things clearly. And I'm going to share this story. This is a hospital who basically, they didn't have those brutal facts. So they had chosen to replace the roof at this building because it was really affecting the doctors on that floor that is right underneath. It was affecting it so much that the doctors complained to administration, and they immediately got the funding because it was a very profitable area of the building. There was a lot of critical operations being done. So they got about $300,000 emergency money to replace the roof to address the leaks. So they proceeded to issue the PO to the contractor, but then somebody asked the question, well, how old is this roof? And then somebody said, oh, it's only 6 years old. What's wrong with this picture? Something's not right. So they didn't have those brutal facts to make that decision. And upon closer review, they realized that whoever had replaced that roof did not address the transition between the roof and the walls. They did replace the roof. It was perfectly done. However, nobody thought about the transition between the roof and the walls. And therefore, where you see that pen sticking out, water started migrating in there, and it affected the whole surface life of the roof. So obviously, the $300,000 would have been another 6 years, and we would have been asking again for the funding. So rather than spending the money on the roof, it was decided to address not just the roof, but also the building envelope itself. So again, it's important to have the right information so we're not reacting to false priorities and diverting money that is not appropriate. So let me give you another example. This is a large manufacturing plant, and how you develop an assessment or a plan to prioritize this large plant is the first step you do is you take this plant and break it down into different roof sections. So again, to develop a prioritized system, you develop chunks of it. You break it down into a grid. you're not going to have a plan to replace the whole roof. You want to have a plan that's systematically approaching it. So first thing you want to do is develop a plan that is broken down into sections. So we have, in this particular case, 6 roof areas that need to be inspected, need to be prioritized. In order to do that, you send somebody who knows about that and inspect it, get those brutal facts. You can see some of the deficiencies that the roof has. In addition to just doing a visual, you also want to do some testing. You want to see the condition that's underneath the roof. So this is an example of taking test cuts so you have that information. Another practice that is highly recommended is to do an infrared scan on your roof, because that tells you information that you can't see with the naked eye. And infrared technology came from the military. You've seen movies, where you see the heat of bodies behind walls and so on. Well, you can apply this to your roofing systems as well as your walls to see what type of wet is underneath the roof. And that gives you information so that you know ahead of time that things are going to start failing if the water continues to be there. Once you do that, what you see on this particular drawing is that out of that entire roof, those 2 sections are the ones that are wet. So, pretty much all the roof is not necessarily wet. The membrane needs to be replaced, but the wet insulation is only strictly in this location. And then what you do is you collect this information and you break it down into sections. So this is an overview of one particular roof area. And something I want to highlight is this, I don't know if you can see it, but it's called Roof Condition Index. So that's a way of rating, again, that question that I asked at the beginning. I need to know how much service life I have left on my asset. Okay? So this scoring system called the Roof Condition Index allows me to say that it's a 15 on a scale of 1 to 100. 100 means I got full life on this, which is typically 20, 30 years, depending on the type of roof. But 15, it means it's in very poor condition. I probably have 2 more years left before it expires. Okay? So that gives me a way of measuring or gauging how much time I have left. Other factors, sometimes you think of roofs, but then you forget about, well, there's also skylights on top of the roof that you need to address. And this is again, going back to that scale, 0 to 100, 15 means it's in very poor condition, so that's a priority for that particular area. This is a tenet that I use, or a principle, and that is, let the conditions dictate the recommendations. Let the conditions dictate the recommendations. So again, we're collecting those brutal facts about our systems so that we can take that information, those facts, and make an informed decision. Okay? So that's a principle that you want to follow. And then, you set out the recommendations. In this case, we're saying let's replace the roof in the future. Lastly, and this is a term that I just learned from one of my clients, they called it a heat map. I thought it was an interesting term. But basically, this is a way of color coding the priorities. So I mentioned, 15s, 30s, and 100, but in this case, area number 1, roof area number 1 on that particular plant, it's in very poor condition. That's why it's in red. That's why he calls it a heat map. Okay? So you can see at a glance what's a priority in my plant. In fact, I've been working on this plant for the last 3 years, so I'm very familiar with it. So here's just another view of it. You can see what percentage of my roof it's in poor condition. And then lastly, we need to answer the question that I mentioned at the beginning. Okay, so I know that my roof is about to expire in certain areas. Well, how much money is going to cost me? Okay, and when is it that I'm going to need those funds? And I apologize for the fine print, but what you see there is a schedule. Okay, I'm going to need this amount of money for 2019, this amount of money for 2020, this amount of money for 2023. That's for capital. And then you also will have funding for preventive maintenance and other types of requests. And here's a breakdown, by year. But again, it's answering that question of how much money do I need in order to implement my strategy. And then lastly, okay, so we've been talking about just one particular building, but then you roll that up to a large portfolio. So in this case, you have multiple buildings. You have the main campus, another, the Strawberry Hill campus, the Energy Center, and you may have, 5, you may have 100 buildings, but again, you have a systematic way of approaching this. So that's an example of prioritizing your roofing systems, okay, which is a very important component of the building envelope system. The next example that I'm going to show you is how you prioritize your exterior facades. Again, I'm thinking of the envelope as a complete shell that's protecting the building from weathering, from affecting the interior. So here's an example of a plant that I worked on, and essentially what you see here is a layout of just the buildings themselves, the facade itself. And then just like with roofing systems, you systematically go around the plant and start reviewing the condition of the different systems. So for example, this cladding system is failing. I mean, it's clearly failing. We actually had to remove a portion of it. There's some masonry issues. Here's an example of a fairly dramatic situation. Actually, this was above the entrance of a hospital, and it happened on a Thursday. Obviously, there's pedestrians coming in and out. But unfortunately, the challenge you see here is a little bit, you don't know the story behind it, but they've been seeing this, but they kept caulking it. And eventually it snapped. Why were they caulking it? Because they couldn't get the funding, until an emergency happened. And unfortunately, that's sometimes the only way you can get their attention. Sometimes when you're doing an assessment of your facades and you're having leakage issues, you can't see it visually. You have to do some exploratory openings. So this is an example where you may have to open the wall and then recognize that, for example, in this case, there's some flashing issues that are not properly done, or an indent that was not properly installed. Another tool that you can use is a borescope. A borescope is basically a camera on a cable where you can get behind. If you don't want to do some destructive work, you can use a camera to see what's going on inside the system and determine if there's a breakup. Another way of testing your envelopes is to do some testing of the sealants. So in this case, you're testing the adhesion of the particular sealant, and that tells you how much life the sealants, if you do some representative testing, how much service life of the sealant has left on the wall. And that way, if you quantify everything, you can start planning for replacing the sealants. Sealants do have a particular service life, despite, sometimes we think they will last forever, but they do have a specific lifespan. Another tool is it's what's called a rallium tube. On walls, an envelope, you can put a sealer as an additional protection to the walls, but that sealer eventually starts wearing out. So this is a way of testing. You put some water and you can start seeing how much is pouring inside the building. And here's some other ways that you can do. Sometimes you have very difficult leakage issues. I have many cases where I get a call or I visit somebody and they say to me, it leaks every time it rains, but only if it rains this way, in a driving rain or in a particular area. So it's very difficult because it's intermittent. You don't know when and how to fix it. So there is systematic ways of water testing your walls. You can actually use certain standards to determine that. And here's some examples of that. You can use, for example, a rack system to replicate a driving range, and that way determine why is it leaking. And then based on that analysis, you can come up with some solutions. Okay, here's the solution for leak area number 1, leak area number 2, and then there's specific budgeting for addressing those leaks. So one way to plan for your building envelope is to systematically prioritize everything, from a short term to a long range. But sometimes you do have to be very specific. I'm having leaks in this particular situation, so you get a little bit more in depth to analyze that. The other tool that I mentioned in the roofing systems is the infrared. So infrared you can also apply to your walls, okay? But it's a different approach. So for example, for roofs, when you use the infrared technology, you typically want to do it in warmer temperatures, okay? Because that's the way the cameras read, and you have to do it at night in order to make it work. With the envelope, you want to do it in colder temperatures, so you can see the difference of heat between the outside and the inside, and that tells you where there's leakage on the building. Where is the air coming out? Because there's gaps, okay? So infrared cameras, infrared technology is really helpful when you're assessing how watertight or how weather-tight the building envelope is. And then similar to the roofs, you can put together a condition index based on the condition of the walls, okay? So for example, a 0, typically we use a 0 when my team of engineers, for example, go assess a particular envelope, and they come back and they say, wow, this thing is going to fall. We can actually, I just literally had one in Cleveland where they showed me a picture where they could push it and the wall was moving, okay? So immediately we contacted the owner and said, we need to barricade this area and start working towards mitigating this situation. So that's a 0, that failed. A 15 means, okay, we're having some issues, it's urgent, but we have enough time to start getting the funding approved for that. And then so on, depending on the service life. Again, the same tenet applies. Let the conditions dictate the recommendations. If we don't have those brutal facts, we can make recommendations that are wise, This is just an example of the condition index graphically. And then, of course, you develop a budgeting scheme based on the number of buildings and then put together a long-range plan based on that. Okay, so I'm going to transition now to, how many of you have parking structures? Okay, 1, 2, okay. So I'll go quickly on this because we only have a few people, but I'll talk a little bit about parking structures. And parking structures are a unique type of envelope because it's open. It's not closed, but yet it's an important component of your portfolios for some of us. And obviously they're exposed, severely exposed. If you're in northern climates, they're very exposed. You got water, salt, snow coming in, so it affects the performance of those structures. So you need to develop a plan. Oops, sorry, I got it backwards here. You need to develop a plan. So a plan for a parking structure needs to be developed on a by level. Okay, so if you have several levels, you typically prioritize the top level because the top level is the one that's exposed the most. So, for example, I just did a parking structure project in Tampa. And we started bottom down. We started to coat the top because that's going to protect the rest of the levels. Okay, so that's kind of a strategy that most people use with parking structures. I did another project in Green Bay. For those of you who are from Green Bay, I saw a Packers backpack over there. That's very severe weather, so we have to be a little bit more aggressive on maintaining those structures there. Same process, you have to make sure you're inspecting. It's very important that you use professional engineers to assess these type of structures because they're different animals. And typical situations are spalling, a lot of problems with steel issues that start corroding. Corrosion it's a big problem with parking structure. Corrosion creates these pressures on the concrete that start snapping it out and spalling and can create a falling hazard. A tool that my engineers use, and this doesn't look like an Inquisition tool to beat somebody up, but it's actually a tool where you drag, it's a chain drag, where you drag this throughout the facility, throughout the deck, and you can hear the areas that are delaminating. You know, you can hear hollow areas. And what happens is you start mapping those locations and then prioritize those repairs based on that. It's a very unsophisticated tool, but it works very well. So, some other types of material testing. I'm not going to get into this too much, but obviously with salt, it's a big deal up north. And then same thing, you develop a condition index, but now it's very specific, that condition index, to a parking structure, you know, to the types of systems that you're working on. So we talked about roof condition index, the exterior wall condition index, and this is a parking structure condition index. And again, same tenant, let the conditions, those brutal facts, dictate the recommendations that you want to do. And here's an example where you have it broken down by levels. Same kind of coloring scheme. You know, the orange areas are the ones that are in poor condition. The yellow areas are in better condition, so you can have an idea of what areas need to prioritize. It's just a pie chart showing that, and of course putting together budgeting based on multi-year programming for that deck. So now that we have that information, this is important because we want to have a plan, and we need the data that helps us make those decisions. Again, having that data allows us to make an informed decision on where to deploy funding when it comes. Even if you're asking for X amount of money and you get only a partial, you at least know where to go that is the hottest parts of your facility, especially in the envelope systems. So it's important that you have the data in order to be able to use a term from a few years ago, we're shovel ready. You know, we're ready to deploy the money because we know exactly where to go. Where otherwise you're reacting. Again, letting the conditions dictate. And then this is a chart that I like to use to show the usefulness of having a condition index. Okay, so anything that's between a 0 and a 30, those are the areas that are priority. Those are in poor condition. They're coming to the end of their life. So when funding comes, that's where my CapEx goes. On the far left, you have anything that's 70 to 100. Those are systems that are in good shape, but at the same time, just like you have to change the oil in a car, even though it's in good shape, you have to do maintenance on the building envelope. You have to have a plan to maintain it. And then there's a sweet spot in the middle. Those are what I call anywhere between a 50 and 85. Those are areas that there might be an opportunity to, maybe we're not going to do a capital work, but we're going to apply some funding to extend the life so we can defer the capital for later. Those are when you get sophisticated, you can get into those areas and save a lot of money for your owners or for the facility managers or the property owners. Obviously, I'm focusing on conditions, the conditions of the assets. But there are obviously other factors that you probably have to align with your conditions. This is just one example. When, for example, I'm working with a financial institution, and as many of you know, bank branches are always struggling because nowadays everybody's doing online. So do I need a branch? That's the question that my client always asks. Do I need this branch? So every year they're shifting. Okay? So we take this approach. Okay, that particular branch, it's a long-term asset. It's for the long haul. I'm planning to stay here for a while. Number two is, well, we're not sure. It's a market that I'm struggling with. Number three, we're deciding to leave that market. We're just thinking next year we're going to do that. And then number four, we already made the decision. We're not going to put any more money into it. So as you're developing the conditions, you have to also align it with what's the plan for that building. Are they going to keep it in the portfolio, or are we going to divest from it? The other, another factor could be risk. For example, I have a client that wants us to inspect any potential hazards to the public. So that comes first. Nothing else trumps that. Risk to inventory. I have a situation, for example, where a hailstorm affected a building, and they realized that there were about $20 million worth of inventory underneath there. So the money for the roof suddenly appeared. We literally got on the phone, the CFO, which is unheard of, showed up on the call, and he approved the money, which we've been asking for 5 years. But applying risk, if you can start making that case, hey, I need that roof, and by the way, there's $20 million underneath that roof, or there's some type of critical operation. Risk to infrastructure or risk to mission. I don't work with the military, but I have some friends that are in the facilities of military, so they think of terms of, is this building critical to the mission? Can I deploy airplanes or whatever? If it is critical, then I must do it so that I don't have any concerns with that. And here's a simple example. This is a building that looks like a little shack. It doesn't look like a big priority, but this is an energy company, and there happens to be a substation inside this particular tiny shed. But inside, it powers an entire city. So they were having problems with the shingles, and we made it into a priority. It wasn't a big project, but it was a priority because what was underneath affected the entire city if it went down. So that's what I'm going to call the section on best practices as it pertains to prioritization. You collect facts, let the conditions dictate the recommendations, and align them with your organization's goals and objectives and risk. The next strategy is more, how do we approach this from a cost reduction strategy? And just some very top of the waves highlights. When you're looking at particular options, take a look at not just the first cost of the lowest cost, but look at the service life cost, So what do I mean by that? Let's say I'm going to pick a roof, for example. Let's say I can put $100,000 on a new roof, and I'm going to get 10 years out of it, okay? Or I can put $150, and I'm going to get 20 years out of it, okay? And the last one is not a typo. I can do a $150,000 roof that's going to last me 25 years. The difference is you engineer it better so that it lasts longer. But my point is, take into consideration when you get the funding, look at the life cost, the service life cost of what you're going to be investing the monies on. The other, and this is probably more applicable to northern states, and that is think in terms of the bidding process. The earlier your bid, the cheaper it is. Okay? If you do it in the middle of the construction season, you're going to get high pricing. So you have to think strategically when you get those funds, because it really makes an impact. I bid millions of dollars every year, and this is a pattern that we see, that somebody comes in June and says, I got to do this project, and now we're going to pay through the nose. So think in terms of early bidding. Another tool that we encourage people to use is to use this theme of consequence of neglect. If I continue to defer this, it's going to cost you more. There's different ways of proving that. I'm not going to get into it too much. Another aspect of your strategy of cost reduction is make sure you have good definition on the scope of work. Okay? And unfortunately, a lot of people, what they do is when they need a particular project, this happens to be a roofing project, they just call 3 vendors and they get 3 bids, and they pick the low bidder. But the question is, who put that scope? Who put together that scope? So I highly encourage you, you define the scope, or have a professional do the scope, so that when those bids come in, you're comparing apples with apples. If you're just going to the contractors, they're going to give you the best option according to their own approach, and you're not thinking of the service life, what you're getting for the money. You know, for $300,000, am I getting a 20-year roof or a 20-year envelope project? So define it. And I like to use this, what I call the construction pie. It's not a peace sign, but it's basically you want to have a good balance between a good design, you want to have good workmanship, you have a good group of contractors that you're working with, and you have to have good materials. Okay? And obviously, because of my engineering background, I'm more for the design. You want to have good engineering design for your building envelope projects. They're not necessarily just maintenance projects, they're engineering projects that you want to put good design so that you get the maximum service life, which at the end reduces the cost in the long run. Otherwise, you're going to get into this situation where, you know, there's no real, no real point of reference because the quote was without any particular engineering done. And many of us get caught in these situations. And construction is notorious for this, where we have, you know, people pointing fingers to each other. So having specifications is critical. We usually recommend using the CSI. This is very common in new construction when you work with your architects or your engineering designers. Using specifications it's like nobody questions that. But in maintenance, for some reason, with envelopes and roofs, we just call the contractor. We don't have a set of specifications that are based on these sound principles. Another cost reduction, I mentioned earlier this scan that I did, this infrared scan. I showed it to you when I was talking about the roofing. We infrared this roof as part of a capital project. And the reason I'm putting it out here again is because by recognizing which areas are wet, we were able to reuse the insulation in that entire roof, which saved us about $150,000 on the project. Because we knew exactly where the areas were wet and where the other areas weren't. And insulation can be recycled. We can actually reuse it again. So that's another cost reduction technique. In roofs, another tactic is to restore. You can apply coatings to roofs to extend the life. Here's an example of a coating. This is before and after. And that usually, it will add, most of the time, it doubles the life of the roof if you are able to coat it properly. Another strategy for cost reduction, a lot of times I've come to situations where the envelope is in such a bad shape, you just can't, you're going to spend a lot of money trying to restore it. So rather than restoring it, we cover it up, we clad it, and it looks like something modern. But in reality, this is an old building that was falling apart in terms of the masonry. We did some minor repairs. There was nothing structurally unsound, and then we cladded it and made it look a little bit better. With parking structures, it's like I mentioned at the beginning, coating the top deck is a great way of strategizing and minimizing the deterioration of your parking structure. So those are cost strategies. And then I'm going to talk about sustainability. Now, everybody in this room, any architects in the room? Okay, an architect. We're not going to pick on you. But for us, facility managers, sustainability means extending the life of the asset. It's not about coming up with some green product that's going to, I mean, we want to use some of those green products, but trust me, when it comes to the envelope, we want to use tried and proven systems because the weather is very tough. It's very tough. So we have to balance between trying new products versus trying products that are going going to help us extend the life of the systems. Okay? So sustainability for us is to extend the life of the system. And I got a quote here from a colleague. This is actually an intern that worked for us this summer, and I interviewed him. I talked to a few other kids because I was very interested in the perspective of this young generation. This is a young man who's studying, getting a master's in architecture, and he came to work for us, and he said, "Why did you come here? Of all the choices you had," he says, "Because we are really in a great area for sustainability." And I'm quoting here, "The less new buildings that we can construct, the better, because construction is such a huge drain on our environmental resource." So we can make a case for that. Rather than building a brand new building, why don't we repair what we have rather than burning out more? And here's an example. I took this from the National Ready Mix Association, and basically concrete alone contributes 8% to pollution. So if we have to reconstruct something, we're going to actually have a much bigger impact on the environment rather than just having to repair what we have already. Here's another example of how much buildings impact. And then, think about maintenance as being a key part of your strategy. And I want to show you this example because I found it very interesting. This is actually something that Henry also shared with me. This particular building is like more than 2,000 years old, but it's made out of wood. How can you extend the life to that extreme? Well, the reason is because these are temples that come with very specialized craftspeople who are being trained, and every 25 years they have a systematic way of restoring the facility. So if they can do it, we can certainly do it, but we're constantly running against this run-to-failure mentality that our cultures are promoting. But here's an example where it's clearly possible. Another example, this is me in Rome this past summer. I was very impressed because the columns that you see behind are the Pantheon, and they've been there for 2,000 years. So the other option, if you don't want to maintain, is to build something that's like over-engineered, and then it will last forever. But we don't have that luxury. Here's another example. I was in Florence, and this dome has been there for the same amount of time. It's almost amazing how well constructed it is. There's still not a lot of people understanding how the architect came up with this design. Here's a quick review of how was that engineered. And then this is more of a modern, this is actually the school where Henry goes, and he shared this picture with me because the facade of this building, it changes depending on the temperature of the building or the temperature outside. It changes colors. It uses this technology where the envelope is changing depending on the weather. So we're expanding into very interesting territories. But again, those are areas that, as facility managers, this is a term that we use. These type of buildings are the architect's dream and the facility manager's nightmare. If you worked on some of these state-of-the-art buildings, they're very challenging. You can also do some energy calculations. This is a spreadsheet that we use from the Department of Energy, where you can use a case to restore the envelope and how it's going to impact the energy consumption of the building. Another strategy for sustainability is to repurpose. Repurpose, what does that mean? So here's a project that I worked 20 years ago. It was a slab on grade in the middle. It was like a courtyard, very ugly courtyard in the middle of this hospital in Grand Rapids. And I talked to the facility manager and he said, you know what, I've been having a lot of leaks underneath this courtyard. And it's really not a destination. What if we repurpose it? So we did a weatherproofing project. We reconstructed that slab, and made it watertight, but then we came back and put a healing garden on top. Now people walk in, and it's a very beautiful destination for the facility. We spent, the weatherproofing part of the project was about $250,000. We spent another $200,000 to put the healing garden on top, but it aligned with the hospital's objectives, so we were able to justify the funding for that. This is a project in Pittsburgh where we repurposed a roof. We made it into a green roof, so that's another approach. So asset sustainment is a balance between, renewal, maintenance, but ultimately we want to extend the life of the systems to make it, more sustainable. Sustainable meaning, let's maximize the service life of the buildings that we have. So in conclusion, we talked about these three strategies, three best practices, prioritization, knowing your facts, those brutal facts to make decisions. We talked about cost reduction strategies. We talked about a sustainability approach that is, very specific for facilities management. And then, obviously, I started with this foundations of a healthy building, where we want to make sure we have healthy buildings by having good ventilation, air quality, good thermal health of the building, and obviously avoid moisture from coming in. And ultimately, we can attract that talent to come back to the office and use the facilities that we're spending so much money on. So with that, any questions that you may have, suggestions, thoughts? Yes, Mayor?
Our government tax structure is such that we should tear them down and start over so we can get the tax benefit and get better benefits. So we sort of engineered our systems to incentivize people to make new all the time.
Yes.
So how do we fix that?
It's a good question. I'm thinking of the healthcare. For a while, one of my clients was spending literally $1 billion a year in construction because they were getting so much funding from donors who wanted their name, the XYZ Center, Cancer Center, and so on. And so they were able to get, but the roofs were falling apart. So I don't have an answer, but it's something that we need to recognize. It's, and that's why hopefully this type of approach gives you tools to make a stronger business case. And I think we're at an inflection point. I think we're at a moment where funding for new construction is becoming much harder to get. So I think we have an opportunity to ask for funding to restore what we have. Other questions? Yes?
Do you have a reference in mind that you could share for historic buildings that have water penetration in the basement areas? As far as even where to start?
Mm-hmm. Top of the wave, yeah, I do, but top of the waves, those type of projects require exploratories, below grade exploratories. They're expensive. A lot of times they're related to the membrane, the weatherproofing membrane around the walls. Perhaps the drainage system is having some issues. I've done many of those, so we can.
Would you start with an engineer?
Yes, for sure. Yeah, because it's a combination of engineering using a contractor to help you do the exploratories below grade and perhaps even do some water testing. But definitely exploratories is something that I recommend. So. Other questions? Yes?
Hi, so I was wondering if you might have any thoughts around the importance of mechanical insulation in just, preventing issues like mold or, things like that. So because, and do you think that enough attention is being paid to mechanical insulation?
Yeah, great point. And I think it's very important to calibrate, and especially when you're doing a restoration of the envelope with your mechanical systems. My closest example to that is
I work a lot with natatoriums, pools, and that's a critical part. A lot of times, what I've seen with natatoriums, which is an extreme, where there's moisture in the inside and the outside, is that there's not, well, they're not of the what I call the vapor barrier that's protecting the envelope. It hasn't been designed properly. So coordinating between the designers and the construction people to make sure that those systems are calibrated is very important. But yeah, it's important that we calibrate the two, the envelope as well as the mechanical systems. Well, thank you.